All right, today we're going to be talking about Boyle's law. Boyle's law relates pressure and volume. The equation for Boyle's law is P1 times V1 equals P2 times V2. Okay? The 1's refer to the beginning of the story problem, and the 2's refer to how it ends. So let's go ahead and start with our first example. A balloon at 1 atm is 450 milliliters. If the pressure changes to 1.5 atm, what will be the new volume? Now, the first thing I always do is identify my variables. So I look at the numbers and I see what they actually mean. So if I have 1 atm, I know that is my first pressure. So I'm going to label that as P1. 450 milliliters is volume, so that will be my first volume, V1. After, the pressure changes to 1.5 atm. Atm we know is a label for pressure, so that will be my P2, and V2 is yet unknown. Now, before we jump straight into the math, I like to do a little predictions beforehand, observing and predicting. So, observation. Our pressure in this problem goes from 1 to 1.5, so the pressure is increasing. Knowing that this is an inverse relationship, we can then assume that the volume will decrease. We can come back to this later. So, let's set up our work. P1 V1 equals P2 V2. It's always good to write your equation out. Now, I view an equation as a checklist, so we are going to see what we know. P1, we know P1 is 1 atm, so I'm going to fill that in directly underneath. V1 is 450, so I'm also going to fill that in. I'm putting these in parentheses, but that means that they are going to be multiplied with each other. So P1 V1 equals P2. Do we know P2? I look back at my problem. Yes, we do. 1.5. And then V2. Do we have a label for V2? No, we do not, so that will be our variable. Next, I see which side I can simplify. I see that 1 times 450 will still be 450 equals 1.5 V2. My next goal is to isolate the V2, and so I will divide by the 1.5 on both sides. V2 is equal to 300 milliliters. Now, where did the milliliters come from? You can always go back to your story problem, find out what the other volume is labeled. It will have the same label as what is in your example. All right, good to go. Next example, I'm going to encourage you to take a pause. Go ahead and hit the pause button and see if you can solve this yourself. Then go ahead and press play and see if your answers match. All right, first thing we do is label what we know. So, we have 1.5 atm, that will be our first pressure. 2.85 liters, liters is volume, so that will be our first volume. And the balloon's volume changes to 4 liters, so we know that will be our second volume. The question is, what is the new pressure? So let's make our observation and our prediction. We know that the volume in this instance goes from 2.85 to 4, so it is increasing, which means that we can predict that our pressure will be decreasing. So let's write our equation. P1 V1 equals P2 V2. Use it like a checklist. Fill in what you know. P1 is 1.5, so I can fill that in. We know V1 is 2.85, so we can fill that in. Equals P2 we do not know based on the question, so that will be our variable. And V2 will be 4.0. Solve the side that has no variable, so 1.5 times 2.85 gives us 4.275. Bring down the P2 and the 4.0. Isolate the P2 by dividing by 4 on both sides. Once you do that, P2 is equal to 1.1. You ask yourself, what is the label? Remember, If we want to look at the pressure in the problem, it is listed as ATM, so we know that this will also be ATM. You can always go back to your prediction. Previously, we had predicted that pressure would go down, and you can see that yes, indeed it did.